my name is Claire. In this video, I will explain how I completed assignment 1 for COMP3132. I will load the fashion MNIST dataset, explore the data, build a neural network, train it using 2 different settings, and evaluate the result. For question 1, 2, 3, I explored the structure of the dataset. I printed the shapes of the image and label arrays, checked their length, and displayed some sample labels. This helps me understand how much data I'm working with and how it is organized. For question 4 to 6, I focused on image index 5 from the training dataset. First, I printed the raw pixel values, which shows digital content of the image. Then I plotted the image to show it visually. After that, I checked the label and matched it with the class name to understand what item it represents. For questions 7 to 9, I repeated the same process for image index 500 in the testing dataset. I printed the pixel values, plotted the image, and identified its label and meaning. This allows me to compare training and testing examples. For question 10 to 13, I prepared neural network. I imported models and layers from Keras and created a sequential model called my network. Then I normalized the images by dividing by 255 so the pixel values are between 0 and 1. I also flattened each image into a vector of 784 values so it can be used by dense layers. For questions 14 to 16, I edited layers to the network. I edited 2 hidden layers with 512 and 128 neurons using ReLU activation. Then I edited an output layer with 10 neurons using softmax for multi-class classification. Softmax is used in the last layer because it converts the outputs into probabilities that sum to 1. It works by applying exponential and normalizing the values. This allows the model to choose the most likely class. For questions 17 and 18, I trained the model using 2 different settings. Option A uses Atom Optimizer and sparse categorical cross-entropy. Option B uses RMS prop and categorical cross-entropy with 1 hot labels. Both models were trained for 10 epochs using the fit function. For question 19, fashion MNIST is more difficult than MNIST because many clothing items look similar. MNIST digits are simpler and more distinct. That is why MNIST usually has higher accuracy. For question 20, differences in accuracy depend on the optimizer, loss function, and dataset difficulty. Similar classes and limited model capacity can reduce accuracy. These factors affect how well the model learns. For question 21, I use the evaluate function to calculate test loss and accuracy. By comparing training and test accuracy, I can check for overfitting. If training accuracy is much higher, it means the model memorized the data. In conclusion, I explored the dataset, built and trained a neural network, compared 2 training methods, and evaluated performance. This assignment definitely helped me understand neural networks and image classification. Thank you for watching.